Dr. T.V. Geeta, Professor, Department of Computer Science, College of Engineering, Guindy, Anna University. Her special interest, Artificial Intelligence and Natural Language. She has published more than 143 articles in national and international journals. She has guided around 7 PhD students. She has got Young Scientist Award from Government of Tamil Nadu in the year 2000, Chief Minister's Special Mention Award in the year 2002, and Woman of Excellence by Rotary Club in the year 2003.
Welcome to the UGC lecture series. In this lecture, we are going to talk about ER modeling, which we have been talking about in the last 3 lectures. However, in this we are going to talk about how to convert the ER models into relational models. Remember that ER model is the conceptual design of an application, and which we should lead you to the relational model, such that you have the complete table design by the time you finish the modeling design phase. Today's lecture consists of 2 parts: how to understand ER model and how to do the mapping of ER model to relational models, and then as we have already seen, we had also an extended ER model. So, we will be looking at how to convert the extended ER model, map that onto the relational model. So, we are going to basically look at ER to relational mapping. So, ER to relation algorithm consists of the following basic 7 steps. First, we are going to map the ER entity types into relation entity types. Then we are going to map the weak entity types of the ER model. Then we are going to map the binary 1:1 relations, then the 1:n binary relations, and then the m into n. Remember, ER model we are only encouraging that you have binary relationships, we are not going to look at other relationship. And then we are going to map the m into n relational types, and then we are going to map multi-valued attributes, and then we are going to map the n-ary relation types, which is going to be very rare. And then we are going to look at the ER model constructs, which is the options for specialization and generalization and mapping of union types or categories. So, this is what we are going to see in this lecture. So, let us take step by step. Let us first look at the mapping of regular entity types of the ER model. So, for each regular, what we mean by regular here is strong entity type E in the ER schema. We have to create a relation R that includes all the attributes associated with that particular entity E. So, and one of the key attributes of E, which is the primary key which we have designed, that has to be put as the primary key of R. And if the chosen key of E is composite, if you have a composite key, then the set of simple attributes that will form the complex attribute has to be made into the primary key of R, if the primary key is a composite attribute. So, that is the first step. Now, let us take an example. We want to create the relations employee, department and project in the relational schema corresponding to the regular entities in the ER diagram. We will look at the ER diagram in the next slide. SSN, D number and P number are the primary keys for the relations of employee, department and project as shown. So, let us look here, do not look at everything, we are just going to consider some parts of this. So, we have employee, department and project. So, employee, department and project, 3 things. These are all strong entity types: employee, department and project. So, these 3 will form 3 relations, and all the attributes here, you have so many attributes, of which SSN is the primary attribute, and here you have name as the primary attribute, and here you have name and number as the primary attribute. All these together will form the this is the ER diagram which we have designed before. We are going to look at how to convert this into a relational model. So, look at this. This is the employee relationship with SSN as the primary key. Now, if you look here, all the F name, all these attributes, middle name, L name, all these are come as separate attributes in the relational. We do not encourage composite attributes. So, all those are flattened out into what we call as simple attributes. Then we have the SSN, which is there as a primary attribute here. Then you have birth date, sex, address and salary. So, you have birth date, address, sex, salary, and then these we will talk about later. So, these are the attributes associated with employee. Now, if you take department, let us look at department. Department, you have name, number, locations and name, number, and locations we will talk about later. This is split, but initially you will have all that, and then and then project we have. Works on dependent department relations are not because of entity. So, because of entity you have only 3 relations which are defined: employee, department and project. So, that is the first step. Next step is mapping of weak entity types of the ER diagram into appropriate relations. So, for each entity, weak entity type W in the ER diagram with an owner entity type E. So, remember, a weak entity type will have an associated owner entity type. We will create a relation R for this weak entity and include all the simple attributes or components of composite attributes of the weak entity type as attributes of R, but this alone is not sufficient. In addition, what we will do is we will include as foreign key attributes of R of the relation associated with the weak entity the primary attributes of the relation that correspond to the owner. So, whoever is the owner, that owner's primary attribute will also come here as a attribute. The primary key of the final relation, that is the weak relation, is the combination of the primary key of the weak entity as well as the primary keys of the owners and also the partial key of the weak entity type W if there are any partial attributes. So, I will just again repeat it. When we talk about a weak entity type, we will create a relation associated with the weak entity type and all the attributes of weak entity type will be associated with that relation. That is the first part. Then the primary, now this weak entity will be associated with an owner entity. That owner's primary attribute will come here as primary attribute of the weak entity type. Sometimes the primary attribute will in addition contain a partial key of the weak entity type. So, let us take an example again. So, create the relation dependent in this step to correspond to the weak entity type dependent. Include the primary key SSN of the employee relation. Employee is the owner of the dependent weak entity type dependent as a foreign key attribute of dependent. So, we will rename this as ESSN. So, the primary key of the dependent relation is the combination of ESSN and dependent name. This is the partial key, dependent name is the partial key associated with the dependent relation. So, let us go back to the figure. Here you have, this is the dependent relation. So, this is dependent, if you go here, dependent had name SSN, this is the partial key, name, sex, birth date and relationship. So, name, sex, birth date and relationship. In addition, your this is the owner of employee is the owner of the dependent relation. So, the primary attribute of this comes here as the primary attribute of the dependent relation as ESSN, and this along with the partial key which has been noted here as partial key, these two together forms the primary key of this particular relationship formed out of the weak entity type. So, that is the second step. The third step is the mapping of the relation. Now, we have finished with the strong entity type, we have finished with the weak entity type. Next we will go to the, so we will go to the relation between these entities. Remember, this relation relationship as we call it in the ER diagram, the relationship between two entities is also represented as a relation or table in the relational model. So, our next step is to create these tables, so relations. So, for each binary 1:1 relationship type R in the ER schema, identify the relations S and T that correspond to the entity types participating in that relationship, and there are 3 possible approaches to this. One is the foreign key approach. Choose one of the relations, say yes, and include a foreign key in S. In S you include the primary key of T. It is better to choose the entity type with total participation in R in the role of S. So, now what we are talking about, we have 2 entities S and T. Okay. They are the relationship between S and T is by a relationship. That relationship is represented as a relation R. So, we will choose that as R, and then we will choose an entity type or as foreign key the primary key of S, and between S and T you will choose the one, it is preferred to choose the one that has total participation. Remember what is total participation? All the attributes, all the tuples take part in the relation. Example, 1:1 relation manages is mapped by choosing the participating entity type department to serve with the role of S, because its participation in the manages relationship type is total. So, let us go back there. In the previous examples we have seen, we had a manages relationship. So, in that manages relationship, it is a relation between department and employee, manages the relationship between entity department and employee. Now, every employee is not a manager, but every department has a manager. So, that is why you will choose department as the role of S. The second approach is if you have a one-to-one relationship type, it is possible that you merge the two entity types and the relationship becomes a single relation. This is appropriate when both the participations, both the entities have total participation in the relationship. And the third approach is a cross reference or relationship relation option. The third alternative, you set up a different, so in the first one what we were talking about is you choose one of them as the relationship and enter the primary key. Second one, merge the two and form a new relationship. The third alternative is you have a third relation R for the purpose of cross referencing the primary keys of the two relation types S and T. Remember, S and T are the two entity types that are taking part in the relationship. Okay. So, that is the second third step. The fourth step is, that is a 1:1 relation. Now, if you have a 1:n relation type, for each regular binary 1:n relationship type R, for each of that, identify the relationship S that represent the participating entity type at the n side. You have to take the one that is on the n side, 1:n, take the one on the n side. So, include as foreign key in S the primary key of the relation T that represents the other entity type participating. So, take S, now S will be the relation. In this S relation, you have to include the primary key of the R relation. Remember, S is the one that is n, it is participating in the n, and R is the one that has the 1. Include any simple attributes of the S 1:n relation as the attribute of S. So, example, suppose you have a 1:2 relation types, works for, controls and supervision. Okay. For works for, we include the primary key D number of the department relation as the foreign key in the employee relationship, and we call it as D number. So, this is referencing the previous slide, previous lecture. Now, mapping of binary m:(n) relation types. Now, for each regular binary m:(n) relationship type, you create a new relation S to represent R. Okay. Include as foreign key attributes in S the primary key of that represent the participating entity types, their combination, that is, suppose you have S and T connected by R as m:(n), you take both the primary keys of both R and S, S and T, and put it in R. Also include any simple attributes of the m:(2). Relationship itself can have an attribute. Those attributes you have to put in the attributes. So, example, so suppose you have an m:(n) relationship for works on from the ER diagram, and it is mapped creating a relation works on in the relation database schema. So, this works on is between project and employee. So, the primary keys of project and the primary keys of the employee relations are included as foreign keys in works on, which is again a new relation. Remember, new relation is a new table, and you rename it that as P number, project number, and SSN, instead of SSN you have ESSN. So, these two are included as new primary, together form the primary key as foreign keys in the works on relation. So, attribute R's in works on represents R's attribute of the relation type. So, that has to be included. So, the primary key will be a combination of these two. So, that is as far as the that step is concerned. Now, let us look at mapping of multi-valued attributes. Now, for each multi-valued, remember, one attribute can have more than one value. An example was phone number. For that, you create a new relation R. This relation will include the attribute corresponding to A plus the primary attribute K as the foreign key of the relation, and this is done so that you do not have multi-valued relationship. Every multi-valued is considered as phone 1, phone 2 and so on. So, that attribute is taken care of. So, and the primary key of R is a combination of A and K. If the multi-valued attribute is composite, we have to include all the simple components, that is, we have to flatten it. So, now let us take a small break. Welcome back after the break. Before the break, we were talking about how to map multi-valued attributes of the ER diagram into the relational model, and we have just looked at the theory of it. Let us look at an example. Now, let us assume that we have a relation department locations, and the attribute D location represent the multi-valued attribute locations of department. That is, it means that a department can be there in many locations, while D number is the foreign key, represents the primary key of the department relation. The primary key of R is a combination of, so now you have another relationship giving all the locations of a particular department, and the primary key of that will be D number of the department along with the D location. The next step, so we have, as far as we are concerned, we have finished 6 steps. Now, we are going to the 7th step of the mapping, which is mapping of n-ary relation types. So, for now as of now we have considered all types of cardinality of the relation for binary relationship. Here we are looking at n-ary relationship. So, for each n-ary relationship type R where n is greater than 2, that is it is not binary, create a new relationship S to represent R. So, for each of the relation you have to separate it out, again flatten it out. So, include as foreign key attributes in S the primary keys of the relation that represent the participating entity types. So, and any simple attributes or composite attributes mean flatten it out, they also have to be included. So, suppose you have supply in this ER diagram. Now, this is a having 3 entities, it connects 3 entities. So, it is not a binary relationship, it is a ternary relationship. So, this is a supply relation between supply entity and part entity. Supplier has S name as primary key, project as project name and part as part name, and supply has its own attributes. Now, here what you do, this can be mapped to the relation supply shown in the relation schema, whose primary key is a combination of the 3 foreign keys. So, here I have supply. Now, supply is a new relation which relates supplier, project and part number. So, the primary keys of all the 3 are added along with the attribute associated with the supply relationship. So, let us first sum up the mapping constructs and constraints. So, entity type is an entity relation 1:1 or 1:n, foreign key or relationship relation. MS:n you have relationship relation and 2 foreign keys. N-ary you relationship relation and n foreign keys. Simple attribute, it will just remain an attribute. Composite attribute, it will be a set of simple component attributes. Multivalued attribute, it will have a relation and a foreign key. Value set will have domain and key attribute will be the primary key. So, this is a basic mapping. Now, we are going to go into the next step where we are going to look at mapping the extended ER model into the relational model. Okay. So, that is the next step, that is it. So, fundamental 7 steps for mapping a fundamental ER model into relational modeling we have covered. Now, we are looking at mapping ER model, that is extended ER model to relations. So, for that let us first take option for mapping specialization or generalization. Now, convert each now remember what is specialization, right? We are going to, it is like a hierarchy, that is suppose you have employees, you can have manager employees and technical employees and so on. So, so it is a subclass. So, convert each specialization with m subclasses. So, suppose you have S1, S2 to Sm and generalize superclass C. So, C is the superclass having S1, S2, S3, Sm, where the attributes of C are K, A1, A2 to An, and K is the primary key into relational schemas using one of the 4 options. So, you have 4 types in which you can convert this type of class, superclass or specialization generalization into relations. So, first one is multiple relations between superclass and subclasses. So, what you do is you create a relation L for C. Now, C is the superclass and with the attributes of L being K, A1 to An, where the primary key of that L is the K, that is the primary key of the superclass. Now, create a relation Li for each subclass. So, now what you are having, you have first created relation L corresponding to the superclass and there you have put the attributes corresponding to C, the superclass. Its primary attribute is K and its attributes are A1 to An. Now, this K is the primary attribute of also the L, that is the relation created out of C. Now, in addition what you have to do, for each subclass create a relation Li for each subclass Si, where 1 is less than or equal to I, that is the number of subclasses with the attributes Li. So, you will have all the attributes of Li and it will contain the primary key and all the attributes associated with the subclass, and the primary key of the new subclass relation is also the same primary key. This option works for any specialization, whether it is total, remember specialization you had, it could be total, partial or disjoint overlapping. So, it could work for any of that. That is one way. So, what have we done there? We have taken one for each superclass, you have put a relation. For each of the subclasses, you have put each of the subclasses you have put relations. The primary key of the superclass is the primary key of all this. Otherwise, the attributes are associated as it is associated. The second option is you have multiple relations, but only subclass. So, create a relation Li for each subclass Si, and where the attributes are the attributes of Si, and now here is where the change is, and union the attributes of the superclass itself, all the attributes of the superclass along with the where one of it will be the primary key, and the primary key of Li is nothing but the primary key of the superclass. Now, this option does not work in all cases, it will work only when the subclass are total, that is all the subclasses take part only in a total relation. Every entity in the superclass must belong to at least one of the subclass. Only in this condition you can avoid having a separate relation for the superclass. So, this is here you have, this is the ER diagram. So, this is the employee, employee can be a secretary, a technician or an engineer. So, now you map it according to the option A. So, you must have a relation for employee along with all its attributes, and SSN is the primary key, and for secretary you will have a separate relation, technician you will have a separate relation, engineer you will have a separate relation. Here you will have this attribute along with this attribute along with this, and this attribute along with this. So, that is what you will be seeing here. So, this is the relation, that is the superclass. These are the three relations corresponding to the three subclasses, and if you look here, this primary key comes here also as an additional attribute for in each of the subclasses. This we have used the first attribute. Now, let us take another example. This example is vehicle along with car and truck. Now, here what we are doing is we are assuming it is a total participation. Therefore, we are not having a relation corresponding to vehicle. Okay. We are having only relationship for car and truck, but all these attributes will come here. So, you have here vehicle ID, price, license plate number, vehicle ID and license plate number, and you will have price, and then you have number of passengers and maximum speed. Here you will have the same thing. So, this is the ER schema according to option 8B. Now, you have another type, you have a single relation with one type attribute. So, create a single relation L. Now, in the first we had one for the superclass, one for each of the subclass. In the second option we had one for each of the subclasses. Now, we are having a one relation L with attributes of all attributes of S1 union attribute. So, how many ever subclasses you have, for all those subclasses all those attributes you take, no duplicates of course, and the attributes of the superclass, and form a single relationship, and the primary key will be the primary key of the superclass. The attribute, and you will have an additional attribute T. This attribute is called a type or discriminating attribute that indicates the subclass to which that particular tuple belongs. So, the subclass, it is like having a flag saying which that attribute distinguishes between the, for example, in this particular one, what distinguishes is the what attribute distinguishes, that attribute is put as T. Okay. So, that is the third type. In addition to this, you have one more type, which is the single relation with multiple type attributes. So, you create a single relation L with all the attributes like this, and you have T1, T2 to Tm. There we had only a single attribute. Here we have a list of attributes, and how many will you have? How many ever subclasses you have? This is a Boolean type which has 0 or 1 depending upon whether the tuple belongs to that particular subclass. So, this is the ER diagram, again taking the same thing. So, here you have mapping the ER diagram according to this option, single relation. So, you have a single relation SSN, F name, MT, L name, and then you have birth date, address, job type, typing speed, T grade. This is all the attributes corresponding to the particular subclass, and this is the non-joint one. So, mapping using this, where you have flags indicating the same thing. Now, mapping of shared subclasses where you have multiple inheritance. So, a shared subclass such as student assistant is a subclass of several classes, indicate multiple inheritance. These classes must all have the same key attribute, otherwise a shared subclass would be modeled as a category. So, we can apply any of the options subject to the restriction discussed. So, 8C or 8D you can use any of the options. This is a university database again, where student assistant is inheriting from employee and student. So, here you have student, this is corresponding to these, and for mapping a category whose defining superclass has different keys, it is customary to specify a new key attribute called the surrogate key. So, when creating a relation corresponding to that particular category. So, in the example below we can create So, take this example. In the example below, we can create a relation owner to correspond to the owner category and include any attributes of the category in this relation. The primary key of the owner is the surrogate key, which is called as owner ID. So, if you look here, you will have a owner ID corresponding to that. This will be the, so let us take one by one, person with the key. So, person with the key, then you have bank, again you have bank, then company, here there is no problem. Then for this owner relation, you have an owner ID, then you have vehicle. So, for registered vehicle, you have the vehicle number and the license ID. Then you have car, truck, which will have the vehicle ID and the attributes corresponding to this. Truck also you will have those attributes, and then you have owns. Now, please note owns, which has owner ID and vehicle ID and purchase and the attributes associated with this. So, this is how the particular mapping is being done. Now, you come here, you have person, you have bank, you have company, you have owner, you have registered vehicle, you have car, truck and owns. So, please note this owns has, it is an M into N relationship, has been represented using, here in this particular case what we have done is we have associated the primary and the surrogate key. So, this surrogate key, so we are mapping a category whose defining superclass has different keys, it is so here in the defining superclass you have in the defining superclass you have this key, you have this key also, it is taking it from two, it is multiple inheritance. In this case you have to have what is called as a surrogate key. So, it is customary to specify a new key attribute called the surrogate key when creating a relation corresponding to that category. So, that is how we have created a new relation and use that ID surrogate key here in order to do this. So, in this example we have done the mapping of the ER diagram to relational diagram using the first 7 simple steps, and then we have explained how to map an ER diagram to the relational model. Now, in this case what we have done is we have first spoken about how to convert a strong entity into weak entity, strong entity into a relation, weak entity into a relation and so on. In the EER we had many cases where if it was we could create a single, you could have superclass separately and all the subclasses, or you can have subclass all the subclasses separately, or you can have a single relation. So, depending upon the total partial participation and whether it is multiple inheritance, the method in which the mapping is done changes. Okay. So, these are some of the exercises. So, what I want you to do is first I want you to draw an ER diagram about the movie data, and these are some of the assumptions, and then I want you to map this ER diagram, which is for a ship tracking database which is given to you, into the relational model. So, this is what we want you to do as an exercise. So, by this step you would have finished the complete design of the database. Thank you.